Imaginary numbers. Up until Algebra 2, when you get to about this point, you've been told that the square roots of negative numbers do not exist. But for your purposes at that point, they didn't exist. Okay? They do. They are imaginary numbers. The square root of -1 is known as I. And for most of you, that's the only thing you'll know as I the rest of your life. Those of you going into electrical engineering, that may change. I squared then is -1, simply because if I square this side, I have to square that side, again, if I want to get rid of that radical. Over here it kind of houseifies, and -1 equals I squared. And so know those two, or at least know one of them, because if you know one of them, you can get to the other one. All right? So anytime you see a negative square root, you should be able to deal with that. Okay? So right here, all we need to do is simplify. We'll start with some easier ones. Here's how I look at it. You want to break it down into something you know the square root of. I know the square root of 25, correct? I also know the square root of -1. Now, if maybe you forgot what it was, but now we know. And I've changed it into a problem, because if I take the square root of -1 times the square root of 25, that is the square root of -25, right? It's the same thing. But I've broken it down into two things that I know. So if you ever see a negative inside a square root, remember, third roots and stuff like that, this kind of becomes different. But if you see that, just get the negative out by itself as a -1, because then you know that's an I. And I strongly recommend you try and put some kind of curl at the bottom. Otherwise, if you're a little sloppy with your handwriting, it might start looking like a 1, or who knows what it might start looking like. And then over here, it's times whatever this is, which is 5. Normally, you will write the I as if it were like an X in the same location. And so this would be written as 5I is the most normal way of writing it. I5, it's not wrong. It's just not normally how you're going to see it. Okay, so that's probably the best way to do that. This one right here, again, I would break it down into things I know the square root of. What I like to do is get the negative out of there first and then worry about the rest later. Let's get the negative out of there and see what happens. And then we've got the 100. Well, there's no need to even break down the 100 because we know that square root. Right? So once again, we have an I here times a nice easy 10. So 10I is probably the way to look at that. Basically, letter C is on here for two purposes. Number one, to see if you're paying attention. And number two, to remind you of how to break down square roots. Because these first two, if you type in the square root of 25 or the square root of 100, they come out to nice whole numbers. Square root of 27, you type that in, that's not going to be a whole number. Okay, so that's not a simplification. That's a rounding, basically, if you go to a decimal. The other one, paying attention, what do I mean by that? There's no negative. So should there be an I on this answer? No. Okay, some people, you'd be surprised how many get going fast, and all of a sudden there's an I on this answer. Okay, and there shouldn't be. So again, you want to break it down into at least one square root that you know. And if you're talking about 27, well, 4 is the square root I know, but does 4 go into 27? Not evenly. The next square root I know is 9. Okay, does 9 go into 27 evenly? It does. And I like to write the one I know first. You don't have to. Again, I changed it into an equal problem. 9 times 3, that's 27. So the square root of 9 times the square root of 3, that's also 27. Okay? Remember, multiplying radicals is easier than adding them. Adding them has more rules. Okay? Multiplying, just go ahead. And we know that the square root of 9 is just flat out 3. Right? This one turns into 3. A lot of people in the past, I've seen them leave the radical on there. Once you've taken that square root, it's done. It's gone. Because really, you look at it this way, this is at least how I taught it, is the same thing as saying that, right? And then you housify. That's why it's just a 3. Right? It's not 3 square root anymore. Is this one still got a square root on it, though? Yeah, this one does, because there's nothing you can do. Okay? Some of you are probably going to learn that decimal, at least out a little ways. But for our purposes, we want to just simplify. So the best I can do is 3 square root of 3. I can't really do any better. Right? That is considered simplified. Okay? So any questions on those? Okay, so if it's a negative, you know there's probably going to be an I coming along the way, unless the negative's out front. And then that has something different going on. And then if it's something like that without an A, we'll just break it down. Well, let's put the two together then. Here is basically the same example, but a negative thrown out there. So here's kind of how I would look at that. I would do that first. Do you have to do all those steps? No. But I'm trying to show you how you could maybe keep yourself from making mistakes. Right? So I know this one, the square root of -1. Hopefully if you didn't, again, know it at the beginning of class, hopefully by the end of class you can just know it. It is I. Now this one, well, we just broke that one down, didn't we? We know what that is. The easiest way to break it down is, so I know it's hard to believe that that problem and this problem right here are technically the same. I've just kind of manipulated it a little bit. Okay? And so we've got an I here. This is 3. Square root of 3. Now how do you write that though? What's probably the best way? I would say it's probably the easiest way is like that. I strongly recommend you leave radicals at the end. Now I know not all of you had me for Algebra 2, but does anybody remember why I suggest having radicals at the end? You don't have to. The reason I suggest that is sometimes if you get sloppy, is it hard to tell when the radical ends? I think for some of you it is. For example, some of you might start writing and say, oh, it's 3 square root of 3i. Is the I supposed to be in the square root? Does it look like it is here? And it's very hard to tell. And again, you know, some of you don't have the best handwriting. I know I don't. And so that's why I put the radical at the end, because then there can be no confusion. In fact, in some other countries, they tell their students to put a little line at the end like that so they know when it stops. Okay? Which is not a bad idea. Okay? I thought I saw a question earlier, or did we? Got it? Yep. Yep. We still had a little bit of ways to go there. Yeah. So now this one. How much else we got on here? Not much, huh? This last one. Okay. So what I would do, I know it kind of seems like it takes a long time, but I would do it that way. Yeah, and it's funny, some of you will come for help and you'll be like, how do I start this? And well, get the -1 out of there. All right? And so that's I. Is 125 a perfect square? In other words, does it have, like if I type that in, do I get a whole number? Unfortunately not. All right, so we have to decide, well, how do I go about breaking that down? Well, the smallest square you know is 4. Does 4 go in there evenly? The next one you know is 9. How about 9? 16 is the next one. 25 is the next one. Yeah, that's where you finally get into where something's actually going to work. But times what? 5. So once again, that problem and this problem, they're really saying the same thing, but they really don't look anything alike. Okay? And we're still not done. This is I. We know the square root of 25, that's why we chose it. And once again, notice, once I take the square root, no more radical is on there. But if it isn't a radical, you leave it. So again, I would probably write it as that. That way there's no confusion as to what's in the square root, what's not in the square root, all that stuff. You know the 5, done. Okay. So any questions so far on how to simplify the radicals? All right. Next page is, what if you got a bunch of stuff going on and you need to combine some imaginary terms and some real terms? Well, the nice easy thing is that you can combine any real terms and you can combine any imaginary terms. And you can combine any terms that have the same variable. So for example, 7 minus 3. That's something you can actually do. I mean, those are real numbers. Those can be combined. And that is a 4. How about the 5i and the -2i? Can that be combined? It actually can, and you can almost think of it as like x's. As long as they match, you're good. So we got 5i, somebody took away 2i, I have positive or negative? Is there anything more I can do there? Can I make that say 7i? No. Is it okay to have 3i plus 4? Yeah, that's fine. That's the same thing. Okay. Either way is fine in that case. Letter B, I put the parentheses in there on purpose. Should I FOIL B? Yeah, it's not multiplication. Okay, so watch out. Some people see parentheses and parentheses and, oh, let's FOIL that. No, it's just add. So really, is there any reason for me to have those parentheses in there? Because is there anything I can do in here if you follow order of operations? No, I can't do anything in there. Is there anything I can do in there? Not really. So there is absolutely no reason for those parentheses in that problem, other than me trying to trick you. Okay. So can I put the 5 and the 6i together? No, I can't combine that, but I can put the 5 and the -2 together. That's 3. Okay. How about the -8i and positive 6i? Yeah, you can put that together and you get -2i. Is it okay for i's to be negative like that? Yeah. Is that the same thing as 2i minus 3? See, a lot of you kind of shaking your heads no. That is not the same thing as 2i minus 3. Is that the same thing as negative 2i plus 3? Yeah, that is the same thing. Because if you write it this way, the negative's on the correct term, the positive's on the correct term, right? So those are okay, but it is not the same as, that's not the same, okay? Wrong sign on the wrong term, okay? So either way you might notice that I kind of have the imaginary kind of at the end, right? There's no protocol on that, it's just where I like to put it. Okay, any questions so far? I know you've seen it before, so maybe there will be, who knows? Ooh, 3 plus 2i squared. The most common answer to this, 9 plus 4i squared. Well, that's kind of part of it, but that's not all of it, because this is saying to take 3 plus 2i times 3 plus 2i, or times itself. This is FOIL. Okay? Watch out for this one. It's very easy to forget about this one. Okay, so 3 times 3, 9. Because I basically think of it as I have to distribute the 3. That's how I look at it. That's your first and your outside of FOIL. And what happens if you do multiply? 3 times 2i. Can you do that? Yeah, it's just 6i. Again, it's the same thing as if I gave you an x on there. Works the same. Okay? So that's distributing the 3. And then I kind of look at it, well, you have to distribute this 2i. So you got to take 2i, well, maybe I'll do this. 2i times 3. See right here, 2i times 3 is another 6i. And then I have to take 2i times the only thing left, which is 2i. Well, 2 times 2, 4, I times I squared. Okay, we are not done, but there are any questions how I got to there? Because let's face it, if you can't get to there, you're not going to be able to do the rest. Right? So everybody good with the first, outside, inside, last? Again, I just look at it as distributing, okay? Because that's really what it is. It's just somebody gave an acronym to help you out. Okay, on this one, there's definitely some simplification I can do. I can simplify that. I can put those together. 6 and 6 is 12 if you add. Is it I or I squared? Just I. Very good, because if it was x's, it would just be 12x. Anything more I can do? I squared can be replaced by negative 1. That was on the front side. Anywhere you see an I squared, you can replace it with negative 1. So there's an I squared right there. So how is the 4 attached to I squared? By multiplication. So take 4 times negative 1, because you can replace it just like that. Okay. Again, we did that on the front. So it's 4 times negative 1, so in other words, minus 4. And at that point, you might think, oh, there's no more we can possibly do. But actually, now that I've replaced that I squared with negative 1, there is more you can do. I can put the 9 and the negative 4 together. You get 5 plus 12i. So once you start doing imaginaries, they actually simplify more than some of the other binomials we've been doing. Again, this is a binomial, 3 plus 2i. It has 2 terms. Okay. I would like to try letter D right now on your own, please, if you have not already done so. As I walked around, I saw quite a few of you that had this one correct. I think it's probably okay I erase this to have some more room, right? Get that out of the way a little bit. All right. This one is also the same way. It is FOIL, but you might notice this setup from some of the factoring you've done before in Algebra 2. So x times x, x squared. X times 5i, that's kind of a weird one, but it's just 5ix. But something very nice is going to happen with the very next thing I do. It's negative 5ix is the next thing I get. Then take that times that. Now here's where most people will mess up on this problem. It is a negative 5 on the left, correct? And a positive 5 on the right. So if you take a negative 5 times a positive 5, you get a negative 25, and then I times I is I squared. Okay. Basically, the reason those ones in the middle are nice is because they do cancel. Right? And this x squared, not much happens there, but something very important is that I squared can get replaced by -1, and there is multiplication in there, right? And so really, if you messed up on that first sign, it's going to throw you off when you do this, because you now have a negative times a negative, ends up being positive. Do you remember seeing stuff like that in Algebra 2? I threw those on. It was a difference of two squares that you could factor easily, correct? Well, this kind of has that same setup, except it has i's in it, right? Here's a sum of two squares, and what did I always tell you to do? If I asked you to factor that, basically say, yeah, you're done, right? Because there was imaginary involved. So keep that in mind. It might end up helping you see those coming along the way. What I want you to do for tomorrow is finish this one. Now, you may notice how I discussed these. I basically said take that 3, which is the first term, and distribute it, right? Take the 2i, distribute it. Now what you have is basically you have an x out front here, right? So distribute it through everything else over there. And you have a -1. Distribute it. You have a 3i. You're probably getting the idea. Is this potentially going to be long? Potentially. What are the chances some things may combine? Yeah, probably pretty good. I do believe you should end up with a trinomial. No imaginaries in it, I don't believe. It should be because of the way I set this one up. Okay, but it should just be a trinomial, meaning you have 3 terms. All right? If you need any help, find me. I'm in the morning. I'm either getting coffee or whatever. But no hall duty this week.